Another appendix, and since we start talking about the heat capacity, we have an appendix, it's called Appendix D, and this appendix we can use to find the value of heat capacity. We have two Appendix D, or two tables in this appendix. We have table D1, this is for ideal gases, and we have table D2, this is for liquid heat capacity. So your substance, if it's gas, then you will, ideal gas, we will go to this table. If your substance is liquid, we will go to this table. Both tables are, like, you can use the same thing. So it will give you an equation. So this equation tells you heat capacity, and anyone from this subscript can know this is heat capacity at constant volume or at constant pressure? At constant pressure. This is Cp, okay? Divided by R, the ideal gas constants, equal parameter A plus parameter B times temperature, plus parameter C times temperature squared, plus parameter D times temperature cubed, plus parameter E times temperature to the power 4. How you can get the value of A, B, C, D, and E from this table? So again, you have the name of your substance. Let's call, we have methane, for example, and the formula of it, CH4. So the value of A, this will be the value of A. And this one here, this is not B, this is B times 10 to the power 3. So here we have B times 10 to the power 3 equal negative 8.975. So this means that B is negative 8.975 times 10 to the power negative 3. And this is one of the mistakes that students like do in solving these problems. So by mistakes, they can like give the number of B and they say B is negative 8.975 times 10 to the power 3. This is correct. Sorry, this is wrong. Okay, so this is how we do it. B times 10 to the power 3 equal this number. So B times 10 to the power 3 equal the number we have in this column. So we divide, okay, by thousands. So this is why it's 10 here to the power negative 3. Is this point clear? If we do the same thing for, let's say for E, for example. So if I tell you for methane, what would be the value of E? Anyone can give the number? Value of parameter E for methane? Yes. So we have here E times 10 to the power 11, and for methane, it will equal this number, 1.091. So again, parameter E, this will be 1.091 times 10 to the power negative 11. The last column here, we have temperature range. So all of these parameters that you can use in order to calculate like heat capacity for methane, for example, if the temperature lies within this range. So we have this constraint here. Outside this constraint or outside this temperature range, then we have some inaccuracy or some error in using these parameters to calculate heat capacity. So always keep this in mind. The last thing, or the second table, this is the same table. So again, we have Cp over R, the same thing. Okay. And almost we have the same idea. So we have for this substance, ammonia, this is the structure, this is the value of A, this is B times 10 to the power 3, this is C times 10 to the power 6, this is D, and this is the temperature range that we can use these parameters.